Hello everyone, welcome back to the channel. In previous videos, we had discussed two different methods for analysis of circuits, that is mesh analysis and node analysis. In addition to these two methods, we have different theorems as well, which can be utilized for analysis of circuits. These theorems include superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem. So I will cover them one by one, and in this video I will start with the first theorem, which is superposition theorem. The superposition theorem is based on principle of superposition. Now what is principle of superposition? This principle states that for a linear system, the net response caused by any two or more stimuli is the sum of responses that would have been caused by each stimulus individually. Now, when we apply this principle to the electrical circuits or to the networks, then we say this is a superposition theorem. The statement of superposition theorem states that for a linear system, the response in any branch of a bilateral linear circuit having more than one independent source is equal to the algebraic sum of responses caused by each independent source acting alone, where all other independent sources are replaced by their internal resistance. So now what we need to understand that the statement says that the response is algebraic sum of responses when the sources are acting individually. Now which sources? Only independent sources. So the method to solve the problems is a bit different when we have dependent sources as well in the circuit. So all the independent sources, they are considered one by one, and others are replaced by their internal resistance. Now what we mean by response? Response means either current or voltage. To have better understanding of the statement of this theorem, let's consider a circuit having two sources. One is a voltage source, second one is a current source. Current source is applying current I1, voltage source is having voltage V1, and we have three different resistances. Let's say the problem is to find out the current through resistance R2 using superposition theorem. Now, according to superposition theorem, we can find out the current through this R2 once when the voltage source V1 is acting, then when I1 source is acting, then take the algebraic sum of two currents and find out the resultant. So what we have to do when we have this type of circuit, we need to check that how many independent sources are there. So we have two independent sources. We have to find out two different values of current I, that is the current through resistance R2. How to solve this? We say that we have two different cases. Case 1, when only voltage source V1 is active. So when only V1 source is active, what we mean to say that our circuit is now having a voltage source and the current source is now replaced by its internal resistance. Internal resistance of an ideal current source is infinite, so it will be replaced by open circuit. And then we need to find out this current. Now earlier I have denoted it as I. As the current source is replaced by open circuit, so circuit is now different from this case. So I will denote this current as I dash because it's not same as I. Now we can find out the value of I dash very easily. It's a simple series circuit. So it will be V1 upon R1 plus R2 and definitely it will be in downward direction. We can say from A to B. So I dash is flowing from A to B. And then we have to solve this circuit again. Case 2, when only current source I1 is active. So when I1 is active, it means we have to deactivate voltage source V1. Voltage source has to be replaced by in its internal resistance. Now what is the internal resistance of an ideal voltage source? It is 0. So voltage source is replaced by short circuit. We will replace it by short circuit and this will be the circuit. We had already marked the direction of current I. It's I double dash. Why am I denoting it by I double dash? Because again the circuit is different from the initial case where we have both the voltage source and current source present in the circuit. Now we have only a current source. We need to find out the current through this resistance R2. Now we have current I1 flowing over here and here we have two resistances connected in parallel. So we can say we can apply current division rule. So that will give us the value of I dash, I double dash as source current I1 into opposite branch resistance R1 upon R1 plus R2. Now this is the magnitude. Our is given direction is downward, that is from A to B, but as per the direction of current source, it should be from B to A, so it will be minus I1 into R1 upon R1 plus R2. Then now we have the two values of current. Now both are flowing from A to B. One is positive, second one is negative. As per superposition theorem, what we can do, we can superimpose these two currents and we will have the value of current I as I dash plus I double dash. So this is how we apply the superposition theorem. Similarly, we can calculate the voltages as well if it is asked in the question to find out the voltage using superposition theorem. Now let's consider if we have dependent source as well. When we have dependent source in the circuit, how the calculations will be different. Now, when we have dependent sources in the circuit, we know they are not actually sources, they are the representation of different circuit elements. If we have only dependent source in the circuit, that will not supply us any voltage or current because they are dependent upon the voltage or current across different circuit elements, which is totally dependent upon the voltage or current supplied by independent sources. We can't replace them by their internal resistance because we don't have any idea. So let's consider this is a circuit where we have a dependent voltage source, it's current dependent voltage source connected in the circuit. Again, the question is we need to find out that what is the current I, that is the current through resistance R2. Now, how many cases we will have? We will have again only two cases. Once when voltage source V1 is active, second time when current source I1 is active. In both the cases, this dependent source will remain as it is. The only difference will be that as there is change in circuit, there will be a change in current Ix. That has to be reflected over here. Now let's understand that how to proceed in the problem using superposition theorem if we have a dependent source in the circuit. We will have a first case when only V1 source is active. So when V1 is active, we have to deactivate all other independent sources. We have just one more independent source in the circuit, that is current source I1. It has to be replaced by open circuit. Now why open circuit? Because the internal resistance of ideal current source is infinite. Infinite means open circuit. And here we have a current dependent voltage source. Now in initial case, what we have seen that this current is Ix. When there is change in circuit configuration, so obviously there is change in this current Ix. Let's denote it as Ix dash. So that will be reflected over here as 5Ix dash. And our question was to find out the value of I. Obviously it will become some different current. Let's denote it as I dash. Now how to find I dash? It's totally an individual's choice. One can go with mesh analysis, another one can go with nodal analysis. If we go with mesh analysis, then we have to write two mesh equations, first mesh, second mesh, and then we have to find out the resultant current I dash. If I say this is current I1, this is current I2, then we need to find both I1 and I2, and I dash will be equal to I1 minus I2. Now how to write these two equations? That is same as which we had done earlier. And if we go with nodal analysis, then we have two nodes. Out of them, one has to be reference. Second is where we will assign some voltage, let's say Vx. Then we have to write just one equation. We will find out the value of Vx, and in addition to that, we need to write this Ix dash in terms of Vx. So I will write the nodal equation. What is the nodal equation? Let's say all the currents are leaving this node. Then Vx minus V1 by R1 plus Vx by R2 is the current through resistance R2. Then through R3 it will be Vx minus 5 Ix dash by R3 equal to 0. This is the one equation. Then we need the equation of ix dash as well in terms of vx. Now ix dash will be equal to minus of this, because this is the current through R1. We have assumed that it is in outward going direction, but ix is shown in opposite direction, so it will be minus of vx minus v1 upon R1, which means v1 minus vx by R1. Then we need to substitute this value of ix dash over here, and then we can solve. So it's totally an individual's choice that which method is comfortable to you, and always choose one method which will give you the solution in minimum number of steps, whether it's mesh analysis or nodal analysis. Now second step is we have to consider second case 2, when source I1 is active. When source I1 is active, this voltage source V1, it has to be replaced by short circuit, and then we have three different resistances. Here we have current source, then we have current dependent voltage source. Now this circuit is different from the initial case, so this current will be different from this as well as from this case, because circuit is different from these two. So let's say it is ix dash, ix double dash, and this current is denoted by I double dash. So this source will become 5 times ix double dash. So we need to keep one thing in mind, that the controlling quantity is changed in every case. In the initial case it was ix, then it became ix dash, and in this case it became ix double dash. We can't use the same value of ix from the previous case, like from case 1 when only voltage source was active. We can't use this value. If we use this value in this case, then that will give us wrong results. Now again, it's our choice that which method we want to follow. If we go with mesh analysis, then we will have three meshes. Let's say these are three currents, as we have already I1 in the circuit. Let's say it's I4. So we have to write first mesh equation, then second and third should be combined all together since we have a current source common between mesh 2 and 3. And if we go with nodal analysis, then we will have two equations. So you have your own choice that how you want to write. I can write for both the cases. If I go with mesh analysis, then from first mesh I have R1 into I4 plus drop across R2, that will be current current through R2 into R2. Now current through R2 in direction of I4 is I4 minus I2 equal to 0. Additionally, what we get from here, that Ix double dash is same as I4. Then we have to combine mesh 2 and 3 to make a super mesh. The equation of super mesh will be R3 into I2 plus 5 Ix double dash plus R2 into I2 minus I4. that is the resultant current through R2 in direction of I2 only, equal to 0, and then we will have constraint equation. The constraint equation will be I2 minus I3 should be equal to I1. So these are the different equations. You can go with the nodal analysis as well. If we go with nodal analysis, we need to write the value of Ix double dash. The value of Ix double dash will be 0 minus V1 by R1 because Ix dash is flowing towards node 1. 0 minus V1 upon R1. It is minus V1 by R1. This is one thing we need to write, that is a controlling quantity, and we will have the equation of node 1 and node 2. The node 1 equation will be V1 by R1 is the current, by assuming that this current is leaving, this one is leaving, this one is leaving, plus V1 by R2 plus V1 minus V2 by R3 equal to 0. V1 by V2, V1 minus V2 by R3. Then from second node, what we will have? We will have a voltage source common between node and reference. So we will have the value of V2 directly as 5 times Ix double dash. And then you can substitute it in terms of V1 and solve. So in this way, it's totally your choice that which method is convenient to you, in which you are comfortable, go with that one. And also keep in mind that you don't go with the method which will give you the solution in maximum number of steps, because we always want to save that time. So with this, it's sufficient to understand that how to apply superposition theorem. In next video, I will solve the numerical problems based on superposition theorem when we have only independent sources in the circuit.